Good afternoon. This is Vern Danforth. I'm the State CAD engineer here in the Production Support Office and Central Office here in Tallahassee. And this discussion is in regards to the current status of 3D engineered models at the Florida Department of Transportation. Just right off the bat, this is the first slide I like to discuss, and that is where our vision is for 3D delivery within the Department of Transportation. This is the direction that both the software and the department are going to, which is a future integrated model, intelligent integrated model actually, that includes not just roadway, but structures, drainage, ponding, lighting, landscaping, everything that you can see in this picture of the proposed facility, and being able to have an intelligent delivery as we go forward. Now, just to do a brief history, I'll go through a couple things, kind of how we got to where we're at. We'll also discuss when currently you're required, or contract, or I should say consultants or in-house engineers are contractually obligated to deliver and what that requires. What QA and QC is as far as engineered models, some reviewing techniques and checklists for looking at a 3D model, and then also what the current 3D deliverables versus intelligent design models means as we go forward. Just a little bit of history. The Florida Department of Transportation has been utilizing CAD software since the, I guess, late 70s, early 80s. Back then it was mainframe based VMS software. It then went to Unix based, and then eventually PC based, or super PC based if you want to look at it that way. And it was, the base obviously was MicroStation. From back then it was Intergraph. Around, I guess, in the mid 90s, Bentley started MicroStation PC, and Bentley kind of took over the development of MicroStation and all of the third-party applications. One of them is Geopack, which the department kind of chose back in the 90s as their civil engineering or roadway design platform of choice. It was 2D based for a number of years up until around 2008 or 2009, when Bentley bought out a couple of 3D based applications, InRoads and also MX Roads, and they started making a best of breed application, which I'll talk to a little bit going forward here. That was around 2008, 2009. That's when the first 3D capabilities came into play for corridor modeling in around 2009. And it was basically generating a model to be able to produce cross sections versus an application that would draw across 2D based cross sections for plan development, plan production. So there's a difference in philosophy there. One is just basically drawing 2D cross sections. The other one is creating a model, or a model centric for cross sections. Around 2000, about that same time frame, we started an open CAD platform as well, so that consultants and in-house designers could choose what CAD platform, AutoCAD or MicroStation, to use. Up until about 2013, the Civil 3D application was, it wasn't fully developed for Florida Department of Transportation, but around 2013 was when we first delivered the first state kit. We'd been traditionally delivering a MicroStation workspace in Geopack probably since the early 90s. That was all custom CAD configurations for both Geopack and MicroStation. and we started delivering a custom FDOT CAD application for Civil 3D around that same time frame. But basically, since about 2013, the software has been available and capable of creating 3D models for designing models and generating the plans off of the models. On the geopack side, this new technology called Open Roads started around 2013 or so, and but they were also still delivering the old legacy geopack. So that's why moving to modeling hasn't been as fast as we'd hoped, and that's mainly because they're still utilizing some of the old legacy tools within the current SS4 release. But the next release of Open Roads will be completely model-based, and there won't be any of the old legacy geopack. The time frame on when we deliver a workspace on the next version is still open. We're still waiting on some future capabilities within the software. About the time, well, some of the issues that have come up since the time that we started doing modeling was the fact that contractors were already making models from plans. We found that out around 2010, that some of the equipment in the field could utilize robotics or automated machine guidance, in which case contractors that wanted to use that equipment would go ahead and take the 2D based plans and actually contract it out or farm it out to actually make models from the cross sections that were delivered. And then they would use that as a very generic, very rough graded model for them to start doing some excavation and earthwork out in the field. Because of that, you know, we realized that the software had the modeling capabilities and that could possibly be the designer's task. And so we started providing that capability within the software around that time frame. Some of the other concerns were that consultants obviously had been contracted to generate plans. All of the scope of works and agreements were based on producing plans. And now we were asking them to also create models, and that caused a little bit of angst. And obviously, in the most recent past, we've worked on a new, I guess, scope of work document or boilerplate for them to utilize to negotiate up front before they actually get into a contract with the department if a model is required. So that is out there and posted. I'll talk about that in a little bit. Also, another initiative that was formed from the director of design here in central office was a statewide 3D task team, which was comprised of several folks, district engineers, consultants, contractors. We had utility engineers, we had structural engineers, roadway engineers, drainage engineers, and it was all based, or it still is active. It's just really to work out some of the risk associated with creating models and what we want to deliver, what we should be delivering, and what we can possibly take out of the plans in the future. And that is an ongoing task team that will continue to meet as we move forward in this whole process. Also to note here, FHWA, Everyday Counts, they came with a 4 or 5 part plan to really stimulate 3D engineered models, 4D and 5D construction, and we've coordinated with our other DOTs as far as what our deliveries are, what they're going to be in the future. We continue to participate in monthly or bi-monthly meetings on these type of initiatives. So the Florida Department of Transportation is not the leader, but one of the leaders in this whole initiative of 3D engineered models in design and construction. This is just a slide showing the various custom workspaces and the history of them that the department has been delivering. It just shows that we've very mature in creating custom workspaces and state kits for the two platforms. The point here is that we are a CAD neutral or CAD transparent DOT, probably one of the few in the country that accepts deliveries from both platforms. You can see that we're in development over here with the current release of AutoCAD and Civil 3D, as well as the current release of this new software direction from Bentley, which is called Open Roads Designer, that is going to eventually replace Geopack. So that's a little bit of the background. This just shows a slide of the custom workspace or state kit inside of Civil 3D. And you can see that there's several custom FDOT subassemblies out here for generating things on your project, as well as making sure that everything is to the CAD manual, CAD standards, and we also are doing quality assurance by delivering these components in the correct CAD format. We not only have this custom workspace or custom state kit for the Civil 3D environment, but we also have it for the MicroStation environment. This is just a screenshot of the MicroStation environment. And this kind of shows the work environment that designers and engineers are currently working in with this Open Roads technology and Civil 3D technology. You can see that both of them utilize a plan, a model, a profile, and a cross-section sort of working environment, as well as generating the quantities are automatically generated between them as you move forward and model or design. So not only are you placing things in plan, but you're also being able to see how it affects the profiling and the cross-sectioning and the model all at the same time. So there isn't any guesswork. As you build the model, you see the results live, as well as the volumes as they change. So it's all a dynamic environment for the designers to work in. The question that a lot of times arises is just when is a 3D delivery, 3D model delivery required? And it really kind of starts out with programs, I should say projects that are put into the work program database project suite. There's a code out there, 3DPR, which I'll get to here in a second, but that's usually where the project is identified. There's also in the new Florida Design Manual a statement about 3D models. There's also professional service contracts that are that I had mentioned, scope of works documents that will identify what is delivered at the different phase deliverables when you have a 3D model, as well as what's in the CAD manual. So there's lots of places where it's actually documented, and I'll talk about each of these in detail. First of all, project suite. So this is the work program database, and as projects are input, there's a code here in the item segment group that is 3DPR, which is for 3D design model with project delivery. So if a project is put into the work program with that particular code, then it was identified as a potential project for 3D delivery. Usually those are projects that are heavy in earthwork. They have been historically, even though we're trying to get it changed to where it's more than just heavy earthwork. Any project that really requires cross sections to generate the quantities for earthwork, as well as quantities for more accurate quantities for anything on the project, be it pavement quantities or drainage quantities or guardrail quantities, any miscellaneous items like that. Anything that requires cross sections to help you develop some of that information, or a model to help you more accurately generate it, then we would expect that it would be created with a design model, and that if you're creating the model, you should also deliver the model. But currently it is major earthwork projects, any like reconstruction projects, those type of projects that have currently been delivered. And if you were, this is about a month old, but as you can see, there's currently in the work program database 169 projects statewide that are identified for 3D delivery. In the Florida Design Manual, in the new section here, there is a statement about 3D models. Basically, it states that if horizontally and vertically controlled cross sections are required for plant production, then the project should be, a 3D model should be created for it. So there's the statement in there. This is just a screenshot of the professional services contract as it was posted for negotiations. There's a new section 36 on 3D modeling, and it states who's responsible for what the consultant and the internal designers would be responsible for. And then there's also, it's also broken out by phase deliverables, so you can see at what level of model is required at the different phases. So a lot of this is starting to get spelled out in our documents as well. And then this just shows the last page of the 100% plans and the final cross sections and deliveries according to the CAD manual. The CAD manual in section 510 4.2, there's a specific section on 3D deliverables for supporting AMG for 3D design projects. This has been in the CAD manual for, I believe it's since 2015 is when it was first introduced, and it identifies the specific files and the specific folder that are supposed to be delivered with a final project. So it basically boils down to alignments in XML, surfaces in XML, and the line work in either a DWG or a DGN or both for 2D and 3D existing line work. So that's those are the documents currently that support 3D deliveries, 3D modeling and 3D delivery. The next topic is QA and QC. This is just a screenshot out of the old, what is now going to be old plans preparation manual, and it pretty much assigns the responsibility of quality assurance for central office statewide, and quality control the responsibility of the districts and their agents or consultants as appropriate. It's when we think about QCing a model, I usually just parallel it to the process for QCing plans. That's always been the responsibility of the designer. It's been part of the scope of work document. Part of what we pay them for is quality control on their plans, and it's no different for the model. We kind of expect the consultants to go through and check the model for accuracy, check it against the plans, and we do provide a sample quality assurance as far as the CAD environment is concerned. We do provide a QC, what's called QC check for all of the elements that are placed in a design file or drawing file to make sure that they meet the CAD standards. And there's actually a percent compliance that gets reported on, and it's defined in the CAD manual as far as what is acceptable for project delivery. I forget what the number is. It's up in the 90s. I think it's 95% CAD compliance will pass. So that is something that's built right into the software for quality assurance on CAD compliance. For actual model compliance, we really need to start thinking about what type of things do you need to review in a model for quality control, and who actually will be reviewing the model. Again, I just parallel it to who reviews a set of plans. If we're going to start delivering models, and we typically have a set of reviewers, they're also going to need to be reviewing the model. And that includes the designers, the consultant designers, their engineers, the engineer of record, the project managers, both within the consultant office and the district office, district project reviewers, district project managers, consultant project managers, other agencies, anybody that current reviews plans are also going to need to have some capability of reviewing the models as well. Of course, there's other agencies, local cities and counties, permitting agencies, utility companies, and they're all really after trying to figure out how the project possibly affects them or how it affects their particular agency. Obviously, if we start delivering models, construction contract estimators will need to be looking at the models to generate their quantities or to review the quantities that are submitted and find out, you know, just how to bid on a job, as well as the contractors themselves, the people that actually build the project. So there's lots of people that look at these models, and they're all going to be trying to find different things about the model, just like they're looking at different things on a set of plans. And what are they going to be looking for? This is just some ideas that we've kind of put together. Obvious things like, does the model look complete visually? You can when you receive a model, there's lots of tools for viewing a model, and I'll cover that in another slide. But essentially, you're just looking to see, does it look right? Does it look complete visually? Just like if you were driving down the road, if something was obviously not built properly, a shoulder wasn't matching a curb, or there was some slope issue or something, you would see it visually. You can see these type of things in a model as well. You know, are there gaps? Are there spikes in the model? Are there overlaps? Do the transitions look correct? Are you harmonizing with the existing slopes? All of these type of things you can see in a model. They're not as easily to determine in a set of plans as they are actually in a model. So modeling gives you a more complete design. It gives you a better quality design as well. And then you would check normal checklist items, you know, pavement lanes, widths, shoulders, widths, shoulder slopes, sidewalks, curbs, all that type of thing. Super elevation rate changes, slope breaks, transitioning slope breaks between 4-to-1, 6-to-1s, 2-to-1s, whatever. Are they transitioning properly? Anything. This is another big benefit of 3D models, is that you can check clearances, and you can find out where you might have potential conflicts with utilities and drainage structures, or utilities and posts, anything underground that we typically we're not able to see in a set of plans. When you turn on all of the different disciplines, it becomes very apparent to where these type of clashes might occur during construction. So you can readily review these in a model as well. Obvious things like depths, pavement, sidewalk base, anything that has some sort of depth that will generate a quantity, you would want to review those as well to make sure that it's according to the typical section or according to what the design area was for the project. And then because a model is separate from a 2D plan, you would definitely want to make sure the model is matching the plan, and that vice versa, that the plans match the model. This is something that we do a lot of training on. We have a lot of tools within the CAD environment to be able to readily QC one set of lines versus the other. We don't foresee going away from plans anytime in the near future. We believe that plans will augment the model, whereas currently the model kind of augments the plans, but we hope to see that it kind of flips in the future to where we need to make sure that we're copacetic between the two. And then details. There's all types of details that we typically don't worry about in a set of plans. For example, when you stop a curb around a radius and start a shoulder, well, you know, usually a curb has a a positive 2% utility strip and then a sidewalk, and if that stops abruptly and matches up or butts up against a shoulder is going to be usually at a negative 6% or 5% slope. And when those two abut to one another, you don't see that there's a transition detail in the set of plans when you're looking at a top view of it. But when you rotate a model and see that you've got one positive slope butting up against one negative slope, then those are details that need to be worked out in the model that we're currently not even addressing when we create a set of plans. It's not usually something that we as designers and engineers have had to actually worry about, and it usually gets worked out in the field. That's just one of many examples of details that you are going to be more tasked with working out in the designer's office versus actually out in the field. And that's where we see most of the savings in construction, if they don't have to stop to try to figure out how the engineer had planned for these things to transition, when we can actually provide them that detail right there in the model. And then the last thing is validating 3D deliverables. Currently, both the open roads or the geopack environment and the Civil 3D environment create very proprietary models within their environment. And what we need to do to deliver this to the contractor is basically save the files out to a more generic format. Currently, we're using XML files and basic CAD files where we strip a lot of the intelligence off just to be able to deliver the line work necessary and the surfaces necessary for the contractors to load up those files into their specific software in their construction offices, in their field offices. They don't typically have full-blown geopack or Civil 3D to work off of, but they do have other software packages out there, AgTech and Trimble, Leica, that has capabilities of basically creating models from these CAD deliverable files that we can export to. So we have to validate those 3D deliverables before we ever do actually submit them on projects. This is just an example 3D engineered model QC checklist that it could start from. It's the responsibility of the department to provide this list, but we just kind of put a bullet list of things that you would want to check as a starting point. I believe the Turnpike has already has a more robust list that they're providing for their engineered model project. A lot of lists as well. But this is definitely something to start with in negotiations, and it can be, it's not a official document. It's not anything that we are putting as a standard. It's just a sample to start from. So just wanted to add that in there. And if anybody is interested in this, they can contact the CAD office and I can provide you the actual doc file or the PDF file that goes with this particular slide. This is a slide of all of the potential tools for viewing a model and doing some QC on it. A lot of these tools you probably have on your own desktop, even if you aren't a CAD jock like the rest of us are. There's basic viewers out there. More and more are being supported by the department as well as being accepted by the department. Adobe, Bluebeam. We have a number of licenses for Bentley's Navigator tool, as well as their viewing tool, as well as a actual web-based browser viewer through Autodesk, this A360. So there's there's also several tablet applications now with Open Roads Navigator, and there's a BIM 360, that's what this one down here is, that can be loaded on a tablet out in the field, and then the model can actually be viewed in the field with a GPS that's a rough location of where the actual project is, and you can see the proposed plan and model right on a tablet as you're walking around where you're going to be at on that particular project. So as well as I've already mentioned some of the construction software that can view models and can import the files that we're asking the designers and engineers to deliver. If anyone has any questions on any of these tools, you're welcome to submit it or call our office here, the CAD office, and we can provide some phone training or provide you some access to this software as well. There are some non-CAD tools that we deliver for viewing XML files. Well, first for creating 3D deliverables and viewing an XML file, as well as signing XML files. All of the native software that I mentioned over here has the ability to apply a digital signature to the file, whether it's a PDF file or if it's a DGN file or a DWG file, or even an XML file. You can provide secured documents through the electronic signature process for each of these files. Currently, the only thing that's, quote, required is that the project PDF be an electronic signature be applied to it, and that is the legal document. But as we move forward, I'm pretty sure that that engineers and designers may want to also secure some of the 3D deliverable files as well. And so I'm providing this slide just to let you know that the capabilities exist within each of those file formats. This XML viewer is actually an application that was written by the CAD office, so you can utilize this to view any XML file that's created from either software or any software for that matter that represents alignments, profiles, cross sections, or surfaces. If they're exported to this format, you can actually use this CAD delivered XML viewer, or this XML viewer application to view those files as well for their integrity, and just see that it's what the designer had intended to deliver. And this is one of the last slides here. What is delivered to the contractor? Our focus within the CAD office was originally just to be able to provide files that the contractor can build from, meaning that instead of them having to generate their own models off of plans, we could provide them with the files to automatically import and work from in their environment. I say this because the current files in the CAD manual are, like I said, alignments and profiles in an XML format, existing and final grade surfaces in an XML format, the 2D baseline work and the 3D break lines that represent the final surface in a DGN or DWG, DGN being the Bentley environment, DWG being the AutoCAD environment. And from those files, they can basically start grading or start working from for even if it's automated machine guidance paving or automated machine guidance milling and resurfacing. If you can provide them with these files, they can go to work right away. In the future, for other purposes such as estimating, we're going to need to be delivering more intelligent design models. Currently, both the vendors, Autodesk and Bentley, are working with the construction software providers, Trimble and Leica, Topcon, to be able to accept the more intelligent models. And as a matter of fact, there's also a AASHTO initiative for standardizing on this intelligent model format as DOTs move forward in this whole realm in the future. And our office, or I should say our department, sits on that committee, and we're working through some of these issues, what this common intelligent design model is going to be. There's a number of options out there. Some are are specific to a vendor. Some are more generic to an industry. There's other industries that have already moved to this. The building industry, obviously, the aerospace industry, they all deliver intelligent design models. So our industry, the transportation industry, is going to be moving forward, kind of following suit with what some of these other industries have done as well. And so some of the formats out there, IFC, there's also a ICM file that you may have heard about. Currently, that's not anything that we require from the department. It may be something that is added in the near future, specifically the ICM format, until we can get a national agreed upon common format that all contractors will be, and contract software vendors will be able to accept. Whatever that ends up being will obviously get put into the CAD standards or the CAD deliverables as we move forward. We also are, so far we've been focused on just the preliminary or the grading and the paving files for them to be able to work off of. But as we move forward, this whole vision of a total integrated model where we have a complete 3D drainage network with pipes and structures and boxes and culverts and all that completely modeled with its wall thicknesses and inverts and mitered end sections, end walls, all of those will be in the model as we deliver. We're hoping to also be able to deliver the 3D bridge model and all of the components that go into a bridge. Part of the benefits of this is to be able to provide the fabricators or the shop drawings. We don't necessarily need shop drawings if we can provide them a complete 3D structure model of each of the components that goes into either a bridge or the drainage network. Same thing with utilities and the junctions that go with that. Signing signals, lighting, anything that could possibly conflict with something else underground. We would like for all of those foundations to be modeled. Anything that could conflict with clearances above ground, we'd like to have that modeled so we can check clearances, we can check site distances, we can check any kind of conflicts with vertical clearance, those type of things. So all of these really require that we have a fully integrated model in order to be able to check all of these things in 3D. What we currently calculate or try to work out from a set of plans will be a whole lot easier to check and validate in a model, as well as, like I said, some of the interferences that we currently have trouble checking in just a 2D set of plans. So this is kind of the state of where the department is, actually where the industry is as a whole. And obviously we're maturing and we're adding more detail. We're working out some of these details as we go forward. But hopefully this provides some of the background of where we're currently at in the 3D engineered models and delivery. This is a couple of slides of a project that was completed with the 3D deliverables from Superior Construction and Arcadis in Jacksonville. It's the 9B project, where it was completely constructed with automated machine guidance as far as the earthwork and paving. All of those components, construction components, were actually built with that. This is the process that they went through to really do a QC between the contractor and the designers. This was a design build job. The designer would provide them with the deliverables that we already talked about, and then they would have a spreadsheet that they would validate based on what was on the plans, what was in the model, and figure out, making sure that there weren't any issues. So the spreadsheet was developed from the plans, and then the model was delivered, and they put the numbers from the model next to the plan numbers just to validate that what they were getting in the 3D deliverables matched what was calculated in the plans. So that was kind of their QC process for checking the model. This is just a screenshot of what you can see was in the actual model that was delivered to the contractor, with ponds and all of the ramp configuration, all the earthwork. And then this is they did model the bridge in this case, not all the components of it, but at least the proprietary walls and the depth of the actual bridge that was going across there. I don't believe they modeled the piers in this case. But you can see obviously that the final constructed project matches very closely to what was in the model, and they did it in record time, and they apparently saved a lot of money for the department, not only in their original bid estimate because they knew they were going to be getting models, but also from the time that it took. I believe the project was actually completed a little bit ahead of time, even though part of it's still being constructed with some of the miscellaneous items like signing and some of the things that were not provided with a model. But you can see that obviously it's not something that is in sort of in a pilot phase. There's actual facts on the ground all across the state of projects that have been built from models, and that's obviously the direction that the department is moving in. And anything that we can do to assist in moving that initiative, forward, our office is definitely here to assist with that. So that is the last slide I have. This is my name here, Vern Danforth, my contact information. I'd be happy to work with you guys in the future, anything that is required. But hopefully you've learned a few things and maybe have a few more questions for us. Be happy to field any questions through email or through my phone contact in the near future. And that's all I have for this session. So thank you for attending. Thank you for your attention.